Okay, student, let's see what is there in this question. A ball of mass 2.7 grams is released from rest from a height of 28-meter above the horizontal ground. Okay. Show that in the absence of air resistance, the ball impacts the ground with a speed of 23 meter per second. So basically, the ball is just falling here and it is dropped. So the initial velocity is zero, and you have to find the final velocity with which it is going to hit the ground. So in the case of drop, like if you have watched my earlier videos, if you have watched the lecture videos on YouTube, or if you are my student in any private classes where you have done this topic with me, I have told you that the formula for this is velocity is equal to root of 2gh. So if you remember it, you can directly apply the values and get the answer. Okay. And if you don't remember this, then you have to go for the SWOT equation. Like what it will be: v square minus u square is equal to 2as, and we would be using the sign convention. So one direction will be taken positive, another will be taken negative. As I've always said, you can choose any sign convention. In this case, everything is downward. This point will be taken as a reference. So the displacement is downwards, the velocity is downwards, acceleration is downwards. So it makes more sense to take the downward direction as positive. So the final velocity is unknown. Initially, it is moving with zero. Gravity is taken as positive and the height is 28. So there you go. Again, you are having the same formula. The V is equal to root of 2gh. We just plug in our values. 9.8 into 28 square root. So you're having calculator, you can use it and you can get the answer. I will not be doing it. I'll just show you the answer in the mark scheme. So there you go. Even they have directly used the formula. V is equal to square root of 2gh. Plug in the value and get the answer. The answer is 23.4. This is how you do it. Now, in this case, I can address one more concern. Like the students usually ask me that if I'm giving you a formula like V is equal to root of 2gh, can we directly use the formula in paper 2 questions? So you can clearly see here, even in the mark scheme, they have not shown you the complete working. They have directly used the formula like V is equal to square root of 2gh, plug in the value and get the answer. So I don't think there is any problem. Like there are many other formulas, like time period is root of 2h by g, and there are different cases and different formulas. I think all those formulas can be used in paper 2 if you remember them, but they are not given in the data booklet. Okay, so let us go to the next question now. This is part A. Part B, an air resistance force F acts on a ball. Okay, so earlier it was said that there is no air resistance and we were using the formula which was simple kinematics. But in this case now, there is an air resistance, there is a drag force F, and it is also given here that F is equal to kv square. So again, if you have learned this topic from me in any way, you might remember that when we do the drag forces, I told you that usually the drag force is directly proportional to V. And if nothing is given, we can assume that the F is equal to kV. But it could be kV square, it could be kV cube, depending upon the shape of the body, whether the shape is spherical, whether the shape is cuboid, cube, or something else, cylinder. So there will be different values, different formulations. So, but that will be given to you in the question. And you can see here, F is equal to kV square is literally given in the question. So there's no doubt, we can just use it. So F is equal to kV square is the drag force, which is also acting on the body apart from weight when the body is falling, where V is the speed and K is a constant. Determine the units of K in the terms of fundamental units. So we have to find the value, fundamental units of K, not the value of K. So this force is, as per only units are concerned, we can use any damn formula, okay, for the force, whatever you know, like F is equal to M into A. So force can be written as M into the acceleration. I could have written it as Newton, but Newton is not fundamental unit. You want to use only the fundamental units. What are the fundamental units? There are basically 7 fundamental units, but we only need 3 usually, like the mass and the length and the time. So you can express any physical term in these units. There are other 4 fundamental units also, like the ampere for the current and Kelvin for the temperature, and mole for the amount of substance. And then there is one more. Uh, Temperature, current, mole, and there is one more. There is one more. A candela, CD. Yes, candela, the unit for the light intensity, candela. So but we don't need it. So that was in your syllabus earlier, but now that have been removed, so we need not to go into details here. So the unit should be this. So this is k, and the velocity is meter per second, and we take a square here. We're just going to solve it, and we just writing k as the k. Okay, so don't confuse it with kgs. So it becomes kg meter, and the denominator is second square, and we are going to multiply it with the second square and divide by meter square. Second square gone. This meter and meter cancels. So the unit for k is coming out to be kg per meter. Kg per meter. This is how we do it. And let's see what is the answer given in the mark scheme. And you can clearly see they have done exactly the same thing. They are first taking the unit for the force as Newton, but you can't keep on expressing it as Newton. You have to convert it into kg meter per second square. And after that, you just solve it, kg per meter. That's it. Okay, so this is over. Let's go to B2. Describe how the ball reaches the terminal speed. Now, the question is describe. So these are some keywords that you must remember when you're doing these paper 2 questions. Like if it is written describe, you have to just write the statement, no numeric values, only description. Determine means you have to go for the mathematics. Okay, like that. So describe how the ball reaches the terminal speed. It's a very simple description here, that the body is going down and a constant force is acting on it, which is mg, but the upward force is a variable force and it is dependent on the velocity. So as long as the downward force is bigger and the velocity keeps on increasing, the body keeps on accelerating, the velocity keeps on increasing, the drag force will keep on increasing, and there will be a moment when this mg will be equal to kv square, and we can say that f net will become 0. Now once the f net will become 0, the acceleration will become 0 and the velocity with which it is moving will become constant. That velocity will be known as terminal velocity. So you have to just put these things in a statement, in a very small paragraph, and then you can just write it. So there you are. The resistance or drag force increases with speed until it becomes equal to weight. No force, no acceleration, the speed becomes constant. That is the terminal velocity. That's it. Moving quickly to the next thing. Now what the hell is this? Okay, the graph shows the variation with the time t and the speed v of the ball from the instant, like it is vt graph given, until it impacts the ground. So it hits the ground and the motion stops. So motion stops abruptly at this point. So we have to just track it down. So this is this. So 3.2, 3.4, 3.6 seconds, the motion ends. The body falls to the ground. This is how it happens, and we have also done these kind of graphs in our classes, that in the terminal velocity graph, like for the acceleration, sorry, for the velocity is somewhat like this, the acceleration is somewhat like this, because after some time the acceleration has to become 0, the velocity becomes equal to the terminal velocity. So the same graph is now available here. So what do we want to find? State the value of the area under the curve. Now that's very annoying question. Okay, let's see. What happens is, like, these kind of questions, they do come in IB. Don't feel that it might be the first time. No, it's not the first time. There's so many questions based on the same concept. You literally want to find the distance, or you can say the displacement of the body, the distance traveled by the body, which will be given by the area under the velocity time graph that we have learned earlier when we're doing the graph. So this is velocity time graph, and the area under the graph will be the distance or the displacement, because it is in a straight line, doesn't matter. So they want you to find the area, or they might have said that what is the distance traveled by the body. So you would be finding the area after all. How to find the area of this? Like, this thing is nothing. We don't have a mathematical equation. We cannot integrate it to find the area under the curve. We cannot do anything. The only method possible is finding the number of squares or the rectangle or the boxes here like this, number of boxes here, and finding the area of this first box here, like finding this unit and this unit, you will find the area, and then we can say that yes, you have found the correct answer. Quite annoying, of course, because these squares, nobody can count it, I think, with the naked eye at least. Like, how can you do it? These are so many squares, you can't do it. We have to find another method, an easy method we have to devise. Okay, so this value is 3.6, so I am going to give you a method which is quite innovative, but it will give you an approximate answer in that. So let us take a look around it. So what we do, first of all, you would be having a scale and a pencil, and you just put the straight line here, and the straight line which is passing here from 2, and then the straight line passing from 3, and the straight line which is passing from 3.6, like this. So we have divided the graph into this segment. Now, for this rectangle, you can clearly see that we can just assume it to be, okay, what is this value? 9.5. This is 9, this is 9.5. So we can just assume this to be a rectangle. So it will be 9.5 multiplied by 3.6 minus 3, which is 1.6. So the area here is 9.5 multiplied by 1.6. You can use your calculator and you can find the values. Okay, I will tell you what is the value here. 9.5 multiplied by 1.6 is 15.2. Let's say this is 15.2 and all the units are SI, so everything is cool. Now we go for the second thing. Now this is definitely not a rectangle, but this area is very small. We can neglect it. So we just neglect this and we create again another rectangle. So sorry, I think I've done something wrong. Yeah. Oh, wait a minute. There is a mistake here. This is not 1.6. 3.6 minus 3 is 0.6. I was confused. This is 0.6. Okay, sorry for that. 9.5 multiplied by 0.6, so it comes out to be 5.7. Yes, this area cannot be bigger than the next one. Next one was coming bigger. That is the problem. So this is 9.5 and this is 3 minus 2, which is 1. So this area can be clearly taken as 9.5. And similarly in this, so this is the 9.5 rectangle, but this is a lot of space that we have consumed here. So you cannot say that it is 9.5, but we can just assume the average of it. So this value will be kind of this 7.5. So we can take the midpoint here. So 7.5 and 9.5. It can be taken as 8.5. Yeah, so I'm taking this as the average, 8.5. I know this is an approximation, but this is 8.5 multiplied by 1, so I can take it as 8.5. What about this one? So this is kind of like, you can take it as 7.5, but it's almost 50% of this rectangle. So it is 7.5 divided by 2. I think this should be giving us the answer, and we have to add all of these with the help of our calculator there. So 7.5 divided by 2 plus 8.5 plus 9.5 and plus 5.7. So my answer is coming out to be 27.45. Okay, let's see what is the answer. 27.45. What is the answer given in the mark scheme here? Okay, students, so the answer given is 28, which is fair, very, very favorable answer, I would say. And in these kind of cases, you don't get the exact answer. Now it is written here, accept the range between 25 to 31 for those who counted the squares literally. So 25 to 31 is okay for us. So you are getting 27.45. So you can just round it off. You can make it 27 or you can make it 28 meters. No problem with that. Clear? Don't go for 0.45. That is too exact. If you are literally counting the number of boxes, you cannot go for 0.45. So you have to give an integer value. So it either 27 or 28, both are accepted. You would be getting full score for that. Okay, let us move next now. Determine the value of k. Now, the value of k. So from the graph, we will first find the terminal velocity, and the value of k can be found by using mg is equal to kv square, and the velocity is coming out to be 9.5 here. So this is 9.5. Now, what is the mass of the body? And is there anything written about the gravity? 9.81. Okay. So mass is 2.7 grams. Okay. So mass is 2.7 grams, means divided by 1000. Gravity will be 9.81. And we want the value of k. The velocity is 9.5 whole 9.5 square. So again, you can plug in this value in your calculator and you can find the value of k. I think this is cool. Let's go for the mark scheme and see if we have done it correctly. Okay, alternative one, mg is equal to kv square, exactly the same thing that we did, and the velocity is 9.5. Plug in the value and get the answer. So your answer will be 2.9 10 negative 4. I am not calculating these things unnecessarily. It will be wasting or consuming a lot of time. So k value is 2.9 10 to the negative 4. That's very cool. Now moving next, determine k. Yeah, there is another method, but we did not to get into that because the other one is actually the right method. Mg minus ma, we don't want to do it. The ball rebounds from the ground with the speed of 7.8. Now it is moving with 9.5. So the ball is coming with 9.5 meter per second constant speed, and it rebounds with the speed of 7.8 meter per second. Definitely there is a certain loss of energy involved here, isn't it? Because the kinetic energy is changing, the velocity is changing, so there is a loss of energy. The ball is in contact with the ground for a time t. The average resultant force on the ball during this time is 1.1. So the force is 1.1. Determine capital T. Yeah, one moment.